All right, today's October 31st, 2011. We're going to do the self-test from Chapter 3, which is on page 184. The very first question says to put this in standard form. Right now we're in factored form, so I'm going to quickly FOIL what's down there, and then the second question to this we'll do with the rainbow method. So we need to multiply the first terms, 3x times 2x, which will give us 6x squared. The outside terms, which is 3x and negative 9, give us negative 27x. The inside terms are negative 5 and 2x, which is negative 10x. And finally, negative 5 and negative 9 is positive 45. We collect like terms, which are our two middle terms, negative 27 minus 10x, negative 37x plus 45. That's all there is to that question. Okay, same idea. This is 1b. It says to put in standard form. Instead of using the FOIL method, we're going to use the rainbow method. Same idea. We're going to take 6 and we're going to multiply it by both of the terms in the other bracket, which will give us positive 6x plus 12. And then we're going to use 5x and multiply it by both terms in the other bracket. Negative 5x times x will give us negative 5x squared. Negative 5x times 2 gives us negative 10x. I need to rearrange this, so I put the variable with the largest exponent first, followed by the next variables with the largest exponent, and then finally the constant. When we collect the like terms, 6x minus 10x will give us negative 4x plus 12. So they're telling us to go from factored form to standard form. Now normally we're used to seeing an equation that's considered a trinomial, which means it looks...
Isn't that difference in squares?
Yes.
Good job, Austin.
We're used to seeing trinomials, so terms that have 3. The first thing I do is when I'm trying to find factors of something, I should look for the GCF, which is the greatest common factor. When I look at these two, the greatest common factor is 1, which means it won't change anything when I take it out. So there really is no greatest common factor that I need to show. This isn't a trinomial. It doesn't have 3 terms. So it's kind of bringing me down to a special factored form. Does anyone know what this is called? Difference of squares. A difference meaning that subtract it, and of squares means I can find the square root of both of the terms. So in order to solve this, I'm going to find the square root of both terms. It's going to go into 2 separate brackets. The first terms are going to be the square roots of x squared, which are x and x. The second terms are going to be the square roots of 81, which are 9 and 9. And in order to finish this off, I have to put one of the brackets plus and the other one minus. So I'm going to rewrite the final answer. The reason we do this, we'll show by checking, okay? So the reason we do this is we're going to actually FOIL the brackets to show you what happens to that middle term. This is why we only end up with 2 terms in this question. I'm going to quickly do this. X times x is x squared. X times negative 9 is negative 9x. 9 times x, 9x, and negative 81. If you guys notice, our 2 middle terms, because we had one that was positive and one that was negative, they cancel each other out. So we end up with only 2 terms when normally we would end up with 3. That's why we've ended up with a difference of squares. Okay, instead of doing what we normally do to solve this question, I'm going to solve by decomposition, which means this is actually very similar to the shortcut when a is only 1. Here's our b term and our c term. So here's the way we can organize this. You need to find 2 terms that are going to add up to our b, which is 5. Okay? Then you're going to find two terms that multiply to our A term times our C term. This is very similar to what we had done before. We'll put this as your B term, okay? So what that means for this question is we're going to be looking for two terms that add to 5, because that's our B. And then we're going to be looking for two terms that multiply to 6 times negative 4, which is negative 24. So what I'm going to be doing next is another way to do it. So in order to figure out what factors I'm going to be using, I'm going to write all of the factors of 24 out. Now I know it's negative 24. I'm going to show you a faster way of doing this than writing all of the options. We're just going to write the factors of 24. So 1 and 24, 2 and 12, 3 and 8, 6 and 4. I know one of these is going to have to be negative because we're multiplying to negative 4. So that'll help me when I'm doing my adding. One of these terms will have to be negative. When I quickly look at this, I know that 8 and 3 are going to be the two terms. And I'm going to have to make 3 negative in order to add to positive 5. Okay. Now that we have the two terms, I actually have to rewrite the question. So we have 6x squared. Is that right? Sorry, I don't remember. Plus 5x minus 4. These two numbers that I have now, I'm going to use those to split my middle term. So what that means is I'm going to have 6x squared, and I'm going to split 5x into negative 3x plus 8x minus 4. Now if you notice, negative 3x plus 8x is positive 5. So all I've done is made this a little bit larger. Now from here, I'm going to factor by grouping. So I have my two groups. Those are brackets, okay? I find the common factor in each bracket. A common factor for the first two numbers will be 3x, which will leave us with 2x minus 1. And a common factor in the other bracket is 2. Oh, sorry, 4. It's even better. 4, which will leave us with 2x minus 1. Now what has happened is the two brackets are the exact same terms. So I factor the brackets out themselves. It's just like common factoring, which we've done before. And the two terms that are left over go into the other bracket. 3x plus. Okay? Yep. Okay. The way we're used to doing this is we find the factors of our first term are A, 1 and 6, 2 and 3. And the factors of our last term, which are 1 and 4, 2 and 2. We know that the products of those two numbers need to add up to our positive 5. And when we go to put it in factored form, one of these pairings will be our first terms, and one of these pairings will be our second terms. Now when I quickly go through this, 1 by 1, 6 by 4 is going to give us 1 and 24. We know that's not going to work. 1 times 4 and 6 times 1 is going to give us 6 and 4. That won't work. 1 by 2 and 6 by 2 will give us 2 and 12. That won't work. And 1 by 2 and 6 by 2, exact same thing. It's the opposite. That didn't work. So we know that our first column of 1 and 6 won't be our first terms. We can cancel them out. Most likely, assuming that this will work, we'll have 2 and 3. 2 times 1, 3 times 4, 2 and 12. Nope. 2 times 4 and 3 times 1 gives us 8 and 3. Yes, that will work. So, we know that I'm multiplying 2 by 4 and 1 times 3, which will give me 8 and 3. Since 3 is going to have to be negative, that means the number I multiplied it by, which is this 1, will have to be negative. I go to write my first terms in, which are 2x and 3x. The second terms have to go in the opposite bracket of what they are multiplied by. So we multiplied 2 by 4, so the 2 and the positive 4 have to go in opposite brackets, which means the 3 and the negative 1, which were multiplied by each other, have to go in opposite brackets. And we're done. That's the factor form to what we're used to doing. This is question 3a. It says find the zeros, axis of symmetry, and max or min. This is very similar to what we were doing, just a little more added on to the end. So I'm going to quickly show you this, and I'm going to use that method we just used earlier, I just shown you, because this is like the shortcut method to when a is the number 1. We need two terms that add to our b, which is 2. You'll be okay. Two terms that multiply to 1 times negative 35, which is negative 35. So again, I'm going to write out my factors of 35, which are 1 and 35, and 5 and 7. I think that's it. Yep. We know that they need to, it's going to be a negative, sorry, 35 is negative, so 5 will have to be negative in order to add to 2. So we have our two terms. I'm going to decompose them now. So I rewrite the question, x squared plus 2x minus 35. These are the two terms I'm going to split 2x into. So we get x squared minus 5x plus 7x minus 35. So all I've done is I've replaced 2x with two numbers that equal it. Then I factor by grouping. I find the factors of the first group and the second group of terms. The first group, the number is just going to be x. So we're left with x minus 5. And in the second one, we can factor out 7. So we have x minus 5. Both of the brackets are the exact same. We factor out the brackets, we're left with x minus 5 times x plus 7, because those were the two terms that were left over. Now, in order to find the zeros, this is where we have to keep going. This is y is equal to this. In order to find a 0 or an x-intercept, that means we're looking for an x value, and we know the y value will be 0. So I'm going to plug 0 in for y, and I'm going to set both of the brackets equal to 0. So we have 0 is equal to x minus 5. 0 is equal to x plus 7. That means x is 5 and x is negative 7. Okay? So my two x-intercepts are 5 and 0, negative 7 and 0. That's a negative. Okay? So that's A. I found the zeros. The axis of symmetry, I need to add r plus s divided by 2. Now, these are my r and s values. Our axis of symmetry is r plus s divided by 2, which in our case is going to be 5 plus negative 7 divided by 2. Negative 2 divided by 2 is negative 1. So our axis of symmetry, we'll call it AOF, is equal to negative 1. The axis of symmetry is also the x value of the vertex. Axis of, AOS. Thank you. I keep writing of instead of s. So our vertex is going to help us find the maximum or minimum. Yeah. So we need to plug our axis of symmetry number, which is our x value of the vertex, into an equation to solve for our y value. We're looking for it. Oh, that's supposed to be a question mark. Yep. So I can use either factored or standard form. In this case, I'll use the factored form we had. Our factored form was x minus 5 times x plus 7. I'm going to substitute negative 1 in for both of our x values. That means we're going to have negative 1 minus 5 and negative 1 plus 7, which will give us negative 6 times positive 6. And that's another way to know that you're in between the two x intercepts. Our axis symmetry, we should always end up with essentially the same numbers here because it's right in between. Negative 6 and positive 6, we end up with negative 36. So our vertex, oh, here it is. Our vertex value is negative 36. Now, here's what's very important. We need to know if that's a maximum or a minimum. So because this is a positive a, we know we have an equation that opens upwards. And the lowest point is at negative 1 and negative 36. So the minimum, this is the lowest that this will go. Our minimum is equal to negative 36. If it was in a parabola that faced downwards, then we would have some maximum, whatever the highest point would be.
Wow, move your head.
Okay, so remember the first thing we look for when we're factoring is the greatest common factor. Now I need to find the zeros first, so that means I need to put this in the factored form. If we look at this, there's no specific term that's the greatest common factor, except for 1. Now our a in this one is negative 4. We're not used to working with a as a negative number. So what we're going to do is we're going to factor out negative 1, which will flip all of the signs of the terms in this equation. So when I divide each of these, we'll do it in red. When I divide all terms by negative 1, we're going to have the same coefficients. They'll just have opposite operations in front of them. So now that I've done that, our a term is positive. Now that I've done that, I need to factor this. So I'm going to factor my terms. I'm going to find the factors of 4, which are 1 and 4, 2 and 2. And factors of 7 are just 1 and 7. We know the product has to add up to 12. And when I quickly look at this, we're going to be using 2 and 2, and obviously 1 and 7. That will give us 2 and 14. Our 2 will need to be negative, which means our 1 term will need to be negative. So I bring down the common factor of negative 1, and I put 2x as the first term in both. Now, here's a trick. Since the first terms are the same, it doesn't matter about putting these in opposites because they're still going to end up in brackets with 2x. But normally, you always have to go opposite. In fact, we could go opposite. Ready? Here's the idea. Because I multiply 2 times negative 1, 2 and negative 1 have to be in different ones. And because I multiply 2 by 7, 2 and 7 have to go in opposite brackets. But if you notice, we still ended up with a 2x in both brackets. Now that I've done this, I still need to find the zeros, which means I have to set my y value equal to 0. And in other words, I need to set each bracket, we don't need the brackets anymore, equal to 0 themselves. Now I have to solve for x. When I bring 1 over, I'll get 1 is equal to 2x. And when I bring 7 over, I'll get negative 7 is equal to 2x. That negative 1 we had before, okay? Let's say we wanted to get rid of it. So I divided this entire side of the equation by negative 1. And I divided this by negative 1. 0 divided by negative 1 is 0. And over here, it canceled out. So now we're just left with the brackets, okay? Sorry about that. That makes sense? So, I have to isolate for x. That means I have to divide by 2. I'm going to get x is a half. And over here, I'm going to get negative 7 over 2 equals x. I'm going to put them as decimals just because I think it'll make it a little easier for you guys. X is 0.5 is one of our x-intercepts. And over here we're going to have negative 3.5 as our other x. These are our x-intercepts. So my two x-intercepts are at 0.5 and 0, and negative 3.5 and 0. So I figured out my zeros. Next I'm looking for the axis of symmetry, which is r plus s divided by 2. We know that this is our r and our s value. So we're going to have 0.5 plus negative 3.5 divided by 2. That's going to give us negative 3 divided by 2, which is negative 1.5. So negative 1.5 is where our axis of symmetry is, which is also the x value of our vertex, because we need to find the maximum and minimum. So we already found our axis of symmetry now. Finally, we have to figure out if this is a max or a min. Now, because a is negative, we know we're going to have a parabola that faces downwards, which means we're going to have some max value. We have to figure out what it is. We know the x value of the vertex is negative 1.5. We need to solve for the y value. So this time I'll plug it into the standard form, just so you can see the difference. F at x is equal to negative 4 times negative 1.5 squared minus 12 times negative 1.5 plus 7. We'll quickly do this on the calculator. 1.5, 1.5, oh gosh, 1.5, there you go. Squared is 2.25. And because it's a negative times a negative, it's positive 2.25. Negative 12 times negative 1.5 is positive 18 plus 7. Negative 4 times 2.25 gives us negative 9. That's okay. When we add them together, we end up at 16. So we know our vertex value so our max value is positive 16. This is question 9 on the self-test. Question 9 gives us a bunch of points. One of them is rainfall, one of them is yield. Part of this question will be setting up your graph. So you're going to have to follow along in your textbook because I haven't written out the numbers. But rainfall goes from 0.3 to 1.5. The other item is yield. So that means how much crop is yielded. We assume rainfall is the independent variable and the amount of crop you yield is due to your rainfall. So we put rainfall on the x-axis and we put the yield on the y. True. Because rain goes from 0.3 to 1.5, I'm going to make a graph that starts at 0 and goes up by 0.1 each time. 0.1, 0.2, 3, 4, 5, 6. Oops. 10. Oh, that should be 1. What am I doing? This should be 1, 1.1. That's good. 0.4, and technically it needs to go to 1.5. So all the way out here. So we'll move that rain. Okay. Our yield goes from 35 to 418. So I'm going to go up by 50.
So can we do the little squiggly line?
You could, but you're probably going to need, actually that won't work very well. You're going to need to draw the entire graph in order to get the proper shape of the parabola. Okay, so 200, 250, 3, 350, 4, and 450. That will encompass everything. I'm going to quickly plot the points we have, which is 0.3 and 35. That would be roughly here. 0.45 and 104. Let's say it's about there. 0.6 and almost 200 is 198. 0.9, oh sorry, 0.75 and 287. 0.9, 348. 0.105 and 401. 0.2 and 427. It's about there. 130, 135 and 442. About there. I'm so sorry, Carlo. And 1.5 and 418, which is going to be down here. Okay, so we've graphed everything. This was our highest point here. So what it's saying is after a certain amount of rain filled, we actually start losing crop. It ends up killing the crop. There's too much rain. So we can assume that this is our vertex. Our line of best fit looks something like this and comes down, curve of best fit. Now you might choose a vertex that's a little to the left, maybe somewhere here. We're just going to take the point they've given us to make it easier for ourselves, okay? So we're saying that our vertex is at 1.35 on the x and 442. Now, if you wanted to make this easier, because it looks like it peaks up and maybe goes down, we could estimate it to be at 1.4 and maybe 450. We're going to say maybe the curve went a little higher and touched that point there. Either of these will work. They're both good estimations. I'm just going to let you know it'll be way easier if you use this one, 1.4 and 450. You can estimate because the curve of best fit is an estimation. So that's now our vertex when we go to put it in vertex form. We have y equals a, x minus h squared plus k. Our k value is 450. And our h value is 1.4. When we go to plug it in the graph, we get a x minus 1.4 squared plus 450. And now another point, I'm going to estimate where the x-intercept is for our x and y value. So we've estimated our x-intercept to be 2.5 and 0. So that's our x and our y value.
Do you still need it? Oh, right, yeah, my bad.
So our x value, should be 0.25.
Sorry.
So what that means is we plug that value in for the x and the y in this equation. We need to solve for a. Our y is 0. Our a we don't know. X is 0.25 minus 1.4 squared plus 450. We move 450 to the other side. We'll get negative 450 is equal to a. And we need to figure out that bracket. 0.25 minus 1.4 equals, and then we square that, 1.3225. 1.3225. When I bring that over, 1.3225, we'll actually get an a value, so we'll do 450 negative divided by 1.3225. We're going to round it to negative 340. Yeah. So our a is negative 340. So the equation of our line is y. I'll do it in red just so you guys know. Y is equal to negative 340 x minus 1.4 squared plus 450. And that would be the equation.